All right, what's going on, y'all? I'm just posting a quick video about how to do the lab activity. Again, this is not the assignment. This is just the weekly lab activity. What I'm going to start doing next week is on Monday, I'm going to post one without the answers in it so you guys can try and work through it. Then I'll go ahead and post one with answers and me working through it on Fridays. So just remember, this is just whatever lab we do on Monday. You have your activity like we always do during the semester. And then I'll go through it on Fridays. So you have until Friday to ask me any questions. And then it's not due anywhere. This is for you to practice. So I'm going to go ahead and pull up the data and the assignment, and we can go ahead and get started here. All right. So the data is from this gas campaign, from the gas campaign data set that I put on D2L. I'll go ahead and just go through it, right? So this is, you can obviously read this, but we're comparing after a campaign whether or not a family's gas usage changed, right? Their gallons per month. So we want to know if this is feasible and before the government decides to do it on a national level, right? So the conservation campaign is conducted in a small but representative geographical area. 12 families are randomly selected, and the amount of gas that they use is monitored for 1 month before and 1 month after the campaign. So there's the data. It says to enter it, but I already put the file in D2L for you to just open it and use it. No need to worry too much about that. All right, so we enter in the data. We got that all taken care of. You should have, if I were in data view, it would look like this, right? The same as over here. I would change this variable to categorical, but it really isn't going to matter too much because you're not using it. So the first question we have to answer, and you probably know the answer to this one, is that what type of statistical analysis is most appropriate? Well, that would be a paired samples t-test. Why? Because we're using the same families twice, right? We talked about this in the video. It's the same family. We want to note their difference in gas usage. Our null and alternative hypotheses are, as always, that the average difference is 0 and that the average difference is not 0. So I'm going to go ahead, and this is the analysis I'm going to run. There is a picture of it on the assignment, but I'll go ahead and run it anyways. So it's going to be analyze, compare means, paired samples t-test, and you just move it over as you'll see me do here in a second, and then you hit OK. So I'm going to go to analyze, compare means, paired samples t-test, and I'm going to go ahead and do, let's see, did it tell me which order to do? Yeah, okay. So I'm going to do before campaign and then after campaign and just hit OK. It's going to take just a second for the output to pop up. Okay, here it is. A little small here. So as you can see, we have the output, paired samples, paired correlations, and our output here, which is also reproduced inside the document itself. So let's kind of just go through the information so that we know what we're actually looking at and so it all makes sense to you guys. So we want to find out the mean use of gas before the campaign. We just look at our paired sample statistics right here because it's kind of like our descriptives, right? So before the campaign, the average gas use per month was 48.9 gallons. After the campaign, it was 46 gallons. This you can ignore, which I don't know why they put in here, but just don't worry about this box here. It tells us something that we can worry about later. F, what is the mean difference between pre and post campaign gas use? So as we know, when we look at the differences, this is it right here, 2.917. So our average, on average, a family uses 2.9 gallons less after the campaign, as you can see from doing just the math right there. So essentially the standard error, again, we know we can find that, it's right here, our standard error of the mean. And then we have our 95% confidence interval. And as I've been talking about all semester, the confidence interval is important because it's another way for us to tell whether or not something's significant. You see that our confidence interval is 0.708 to 5.125. So does that include 0? No, which is important because if it included 0, that means that we couldn't rule out our null hypothesis of 0. So this is good that it does not include 0. That means that we have a significant finding. So then what do we conclude? Well, we conclude essentially what it says here. We conclude that there is a significant decrease in gas consumption from 1 month before to 1 month after the campaign of gas advertisements. And as you can see, you can tell from your significance right here, this is 0.014 is less than 0.05. And so that means we have a significant difference. So instead of repeating myself, you can just go back and watch the video again. This is all the things you're going to need to know. I'll post some questions. I'll post some answers to some questions about the test on the Teams pages, but this is how you do the activity. Thank you guys for being flexible with how we changed up the course so far. I know this is a crazy time for everyone, and we realize that. So just keep reaching out if you need anything, and I, along with Dr. Ram, will do our best to keep things going for you guys. So with that, I'll say thanks for watching. I guess I don't really know how to end these videos. So.